In the previous video, we ended with the adaptive clearing with the small 1/8 inch end mill, which still left a little bit of material that needs to be cleaned up with a contour. I'm going to be using the same tool, the 1/8 inch end mill, but now I'm using a 2D contour. To save a little time on the video, I've already selected most of the tooth profiles. Basically, the profiles you're going to select are here. Notice when I click, it actually selects down below because the tooth profile is curved. Let me rotate it like this. So you can see that the tooth profile is curved, and this is a two-dimensional contour. We actually want to go full depth. We'll set the depth in a moment, but we want the end mill to follow this path to make sure that it gets full depth in here to clear out the material so the chain fits properly. We will put the curve in the tooth in a later operation. So basically, you just select these edges here and make sure you go all the way around. It's a little bit cumbersome to have to click every single tooth. If you misclick and click something like this, you can deselect it by hitting Control and then left click. And then you can just keep working your way around until you've gone all the way around. Once you have that, the depth, I'm going to go to selection here, not selected contours, and just select down here. You can select maybe this edge here, and then go just a little bit deeper, maybe 10 thousandths. So I have 10 thousandths deeper there, and we should not need to change any of the other settings. We're not having any stock to leave. We don't need to do multiple depths, and we don't need to change the lead-in that I'm aware of. And so we should be able to just hit OK. And visually you can see that we're going in and just cleaning out the remaining material left from the adaptive with that contour. So the next thing that we can do is we'll drill the holes. But before we tap the holes, it's a good practice to put in the chamfer before tapping. So I'm going to drill the holes, chamfer these edges here, and then come back and tap the holes. These are 1032 holes. You can inspect. You can inspect the holes here, and trying to find where it says the size of the hole. Right here, the thread design is a 1032, and so we need to drill this with the appropriate end mill or with the appropriate drill bit so that we can tap it with a 1032 tap. So we'll go drill. Select all the holes. You can select them individually like this, or go just select holes of the same diameter. And the tool that we want, again, go to the VF3 library and we'll do a search. The name is appropriate. You could see right here, number 20. It's a 0.159 drill bit. That's the diameter. It's a number 21 drill. That's a tap drill for 1032. You can check that with the drill chart as well. So I'm going to select that drill bit here. And again, the speeds are set for aluminum. You don't have to worry about changing the speed or the feed rate. We have the geometry, the depth. You definitely want to go all the way through the material, the stock material as well. And so I'm just going to go to stock bottom, and then we'll have, there's the bottom of the stock. We want to make sure that the tip goes through the bottom, and then maybe some additional breakthrough. There's nothing there. The standoff or the parallels are on this edge here and this edge here, so there's just air down below, and so the drill bit isn't going to hit anything. With this deep of a drilling, over a 1/2 inch of material, or at least it is 1/2 inch material, we want to make sure that we're not just doing a straight drill. Typically I do drilling, chip breaking, which is a partial retract, or deep drilling, which is a full retract. Basically this allows the chips to be removed we'll just do a deep drilling full retract. And it does take a little bit longer, but in short, the drill will go down and come all the way back out and let the coolant wash out some of the remaining chips, and then it will go down a little bit deeper, come out. You can see that the pecking depth is just under 40 thousandths. We could probably set that a little deeper. I'm just going to go maybe 125 thousandths, which is an eighth of an inch. And we don't need to have it dwell at the bottom. This is if you want a little pause at the bottom, you can set a dwelling period, but we should not need to do that. So hitting OK, we now have the drilling part done. Next, what we're going to do is a chamfer. We're going to put on all these little chamfers here. So I'm going to do a two-dimensional chamfer because these are all on a flat surface. And the tool that we're going to use is a chamfer mill. I do not have in the machine currently a 45-degree chamfer mill. I have a 41-degree chamfer mill. This is close enough to 45 degrees that it really doesn't matter for us. The reason why we have this one is this is the correct angle for flathead or countersunk screws. And so we use it for both purposes, to put chamfers in and to make countersinks. So I'm selecting this tool here. I'm going to select these edges. Okay, right here. The chamfers here are already modeled. There are some occasions where you want to chamfer something and the chamfer isn't modeled. Like in this scenario, notice there is no model, but there may be an occasion you'd want to put a chamfer. The settings are slightly different, so I'm not going to try to chamfer this edge and these edges in the same operation. We don't need to chamfer this edge. On a later part, I'll show you what the settings look like when you don't have the chamfer modeled. So we have the tool, we have all the geometry selected. The heights, we do not need to change anything there, but there are some settings here that we do need to look at. Okay, the chamfer width is really the horizontal width of the chamfer, but this one is already modeled, so we're just going to leave that as 0. The chamfer width offset is basically the tip of the chamfer mill is offset from this line a certain distance. And you might wonder why we would want to offset it at all. And the reason why is the chamfer mill has a flat bottom. And so we want to make sure that the edge of the chamfer mill, or the angled edge of the chamfer mill, is hitting here, not the flat bottom. And so this is a pretty large offset. I'll leave it at 40 thousandths and then we'll change it up a little bit. This is the chamfer clearance. Sometimes we want to make sure that the actual tool clears other material that is not supposed to be chamfered. However, since the chamfer is already modeled, it typically this needs to be set to 0. If I don't set it to 0, I don't think it will model the path. And I'm going to hit OK, and let's see what happens. And you can see that there's a little check mark there, so that there's some problem. And if I right-click on this and I go to Show Log, it kind of gives me a little bit of information. And it says there's an empty toolpath. If you're machining a chamfer that is modeled, try setting the chamfer width and chamfer clearance to 0. So I'm going to go back here and go to the chamfer clearance, setting it to 0, and let's see what happens. Okay, so you can see that everything is modeled. Notice that the path seems really far away from the actual chamfer, and that's because of the chamfer width offset. And it still works, but I'm going to simulate it, and let's kind of see what's going to happen, and then I'll reduce that offset to see what it looks like. But this will work. But let's take a look at what's going to happen. Notice the flat bottom. That's the whole reason why we have the chamfer offset. and you can see that this edge is now being chamfered. Notice the angles don't match up perfectly because in the model it's at 45 degrees and this is a 41 degree chamfer mill, but for our purposes it really does not matter. So this will work. Let me just go quickly and change that offset to some smaller number so you can just see the difference. Let's go to maybe 20 thousandths. So this is now wider. The chamfer mill will be higher up on the part, and all of these paths are, yeah, a little bit larger diameter. And so let's simulate that. It's going a little fast here. Let me pause it. So you can kind of see it's still doing the chamfer properly. But that offset has to be there, or this would be following the path and it would leave like a flat edge here, a really rough edge. So we want to make sure that the angled part of the chamfer mill is what is actually following that contour. So now that everything is chamfered, we can tap these holes here. So we can go just to the drilling again and select the holes. We can just select all of the same diameter. The tool is now a tap, and so we need to find that. I don't have the number memorized, but it's a 1032 tap, so it's number 24. You can see there it's a 1032 tap. We're going to select that. And the depth, we want to go all the way to the bottom of the stock. We're just going to go stock bottom, and we're going to go all the way through, again, maybe another 20 thousandths or something, making sure that the threaded part goes all the way through. Notice it probably isn't necessary that I go that deep because we're going to be machining all of that off, but I do want to make sure the threads are full size threads all the way through. So going to the next step, we want to make sure that we're tapping. Now, this is basically, if I don't change the setting, it's going to just tap in a single step, and that is a lot of depth to do in one tap. Typically you do it and then you break the chips, you come out, and then you go back in a little bit further. So we are going to do tapping with chip breaking, and then it has the pecking depth. That's how far it taps each step. We can go more than 40 thousandths. I think we'll go again 125 thousandths, or an eighth of an inch. You can put a dwell period. I don't think that we need to. That's again a pause at the bottom. Realize that the machine has to synchronize the Z movement, the Z speed, okay, with the angular speed of the tool. And then when it comes back out, the tap has to spin in the opposite direction. And so that's all done for us here. But we'll hit OK, and I think we're good. So now we have the chamfering, the contour, and the tapping. Really all that's left is getting this profile done, and I'll do that in the next video.